this goes over work done. So work done is basically just the term in physics for when something is moved, okay, so, or when energy is changed to another form. So obviously there are different types of energy. There's kinetic energy, which is movement energy. There's potential energy, which is to do with gravity. And there is frictional, well, that's chemical energy. Let's call that. And okay, there's also heat energy. Now, heat energy is often kind of comes around from friction, and friction can be caused by air, water, and other things. Okay, so to start off with, let's think of work done as a kind of formula. So work done equals force times distance. Now it's important to remember the units of this. Okay, so work done is always in joules, force is in newtons, and distance is in meters. Okay, the reason that's really important is because if you transfer meters into centimeters, you're going to have twice as many joules at the end, aren't you? Or I mean, you're going to have 100 times more joules at the end. So that's because 1 meter is 100 centimeters. So let's say we're moving something like a box up a hill with a force of 5 newtons per, and it's going to go up 10 meters. Okay, then the number of joules would be obviously 50. But if we got the units wrong and we put 5 newtons, but we put this in centimeters, then we'd have 1,000 centimeters. So that would be crazy, because it would then take 100 times more joules of work to get it up the hill. So remember your units, because they can really screw you over if you use the wrong ones. If you use centimeters instead of meters, you'll get something 100 times bigger for your answer, and you won't get the mark. Okay, so now to kind of give you a context for work done. So imagine something's pulling something up. For example, let's say we're at a car trash yard, right? Okay, and you have a massive electromagnet and it's attached to a crane. So it needs to pull up the car. Let's change this into a car. A rubbish looking car. Well, it's at a trash yard, so it should look rubbish. Okay, and then it has to take this car up 10 meters, and it's going to take a force of, let's say, 100 newtons. Okay, so the force is going to be proportional to kind of how heavy the car is, how much air resistance there is, and other factors. But in your exam you'll just be given the force in newtons, and you'll be given the distance in meters, hopefully, or you might be given it in centimeters and you have to change it. But either way, you need to be able to do this calculation. So the calculation for work done is, in this scenario, it is 10 meters times 100 newtons of force equals 1,000. So it's 1,000 joules. It's always joules. Okay, so now some examples. If you're, I don't know, if you're going up a hill, this is a classic example. If you're going up a hill, you might start off with a lot of kinetic energy. Let's say you're running at the bottom of the hill, or actually, cycling is a better one. Okay, so or anything on wheels, really. Just imagine that as anything on wheels. Can be a car, can be a cycle. A cycle's probably better because it uses energy that you use. Okay. So, awful looking cycle, but it starts off with kinetic energy. Let's say the kinetic energy is like 100 joules at the bottom, or 1000 joules, and at the top, well, halfway, okay, let's go steps. Halfway it could be 500 joules of kinetic energy left, because you've used a lot of that energy going up the hill. You're going at less speed by the time you reach this point, because you've lost that energy getting yourself up there. So it would then be only 500 joules of that left, and 500 could be converted into potential energy. Potential energy is to do with like the height you're at and the amount that gravity can act on you to pull you back down. And then when you get to the top of the hill, you might have almost stopped completely or lost all your speed. So you might be at, let's say, 10 joules of kinetic energy, and you might be at 990 joules of potential energy. Okay, so that's an example of potential energy and kinetic energy, and it's work done because you're changing from one type of energy, one energy type, to another. In this case it's kinetic energy to potential energy. Okay, so work done is force times distance. If you're trying to work out the joules used up, or work done is a transfer between energy types.